Today, I'm going to talk about ad hoc networking wireless systems. Previously, we developed video discussing wireless emulation system hardware and software. You can view that at the link on this slide. The focus of today is about wireless networking. Specifically, we will talk about routing protocols. If you look at the diagram here, you see that we have client and then we have relay systems. And for example, if a client want to talk to from here go to a base, they may go from here to a relay system and then go to the base. Okay, and in this case, each of these is called a hub. So from here to here is one hub, from here to here is another hub, and you're gonna hear that in a demo later. So the concept of wireless networking is an ad hoc method. So it uses no infrastructures, unlike the wire networking method that you typically see with Ethernet. The complex MANET use the relay or gateway systems. In this case, a system on something like a Humvee or a helicopter, for example. And typically, the gateway system is much more powerful than the handheld device that a client have. Okay. So for wireless networking protocol, there are mainly three types. It's called active, reactive, and hybrid. The example for active is something like OLSR, which is optimized link rate, link state routing. It actively updated the network information and is better for latency. There's another concept is reactive, which is AODV, for example, and a combinations of these two is called a hybrid. I'm going to talk a little bit about the demo system so that you're familiar with it before we show it to you. We use two Linux clients in this case and go through another system emulating the relay. So you're going to see that. And the software running on these shown in these diagrams here. And each of these has OLSR software running on it as well as applications. So the way the demo is set up is we divide that into 6 windows, okay? And these windows are mainly for the client 1, and these windows are for client 2. And in this window, these are the relay system windows. So on the top here, we will run the routing protocol. So you're going to see that actively running and displaying as it capture informations. And the lower ones are the running of the application itself. In this case, we just use a simple ping to show you the routing mechanism. Okay, so this will be client .30, and this will be the relay system, and then this will be the client .95 system, and you see messages will be transferring between them. Okay, so next we will do the demo itself.
Today I'm going to do a video demonstration of optimized link state routing protocol, which is also known as OLSR. As you can see, I have logged into 3 different systems. The one is 0.175, other is 0.184, and the third one is 0.206. Here the 0.184 system acts as a host, while the other two systems act as a client. I have already created a hotspot on the host system, and both the clients are connected to the host through hotspot. Any direct communication between client 1 and client 2 has been blocked since they are placed close to each other. Now we will see the IP addresses of client 1. As you can see, the IP address of client 1 is 10.42.0.30, and the IP address of client 2 is 10.42.0.95. I'll do a ping from client 1 to client 2. Here we can see that there was 100% packet loss, which means that there is no direct communication between both the clients. Now I will run the OLSR code on all the three systems. The wireless interface name on client 1 is WLP2S0. Similarly, the wireless interface name on client 2 is WLP3S0. I'll also run a OLSR server program on the host system, and I'll run the OLSR program on the QEMU. The QEMU is booted up on the host system, and the process to boot the QEMU is already explained in our previous videos. The main function of OLSR server program is to receive and transmit the UDP broadcasted packets and to communicate with the QEMU. As you can see on client 1 that a neighbor table is formed with the IP address of the host and the IP address of client 2 at a distance of 2 hop. Similarly, on client 2 we can see that the host address is at 1 hop and the IP address of client 1 is at a distance of 2 hop. Now I'll do a ping from client 1 to client 2. Here I'm using the Linux inbuilt ping command with the option of -r to see the routes taken by the ping request. Now as we can see that the route taken by the ping request was from client 1 to host to client 2, and we get a reply from client 2 to host and client 1. Here we can see that 2 packets were transmitted and 2 packets were received with 0% packet loss. Similarly, I'll do a ping from client 2 to client 1. The IP address of client 1 is 10.42.0.30 with the option -r to see the routes taken by the ping request. Here we can see that the route taken by the ping request was from client 2 to host to client 1, and we get a reply from client 1 through host to client 2, and there was a 0% packet loss. So now if I turn off the OLSR program on client 2, then we should not be getting any response from client 2 if we do a ping on client 1. So let's try that. I'll do a ping again from client 1 to client 2. As you can see that 2 packets were transmitted and there was 100% packet loss, which means that there was no response from the client 2. And on the neighbor table, if you see that we only have one IP address, which is 10.42.0.1, which is of the host system. Similarly, on the host system, there is only one IP address available, which is of client 1. Thus, by this video, I intend to show the working of OLSR on the QEMU emulator. Now, just to summarize, we demonstrated wireless ad hoc networking through OLSR, which is optimized link state routing protocol. We also showed that how OLSR program detects the neighboring nodes and create a routing table. Through the demo, we also showed that how client 1 communicates to client 2 through the relay system, which in our case is the host system. Thank you for watching the video.